Hi there, welcome back to the next video, and in this video we will see the k nearest neighbor algorithm in the Python, or the short name is KNN in the Python. In the previous video you have seen that how I have walked you through the theory of the KNN algorithm and identified the neighbors that you require, and finally we saw an example of the cancer data, the breast cancer data within the R programming. So today I will going to show you how you can implement the KNN algorithm within the Python on a different data set, which is a pretty familiar data set to you. So once you will see it in the example, you will see that since we are beginning to start using this data set or start using this algorithm within the Python, so I'm keeping it very simple so that your learning curve is very quick and you should be able to do most out of this exercise and then implement it on the other examples. So let's go ahead and see it in action. Alright, so let's go ahead and start doing or start importing the libraries for the reading the data and to import the k nearest neighbor library. So first of all, import pandas as pd and then from sklearn.neighbors import k nearest classifier. So as you know, in the previous video, in the theory video, I have explained that you have two different types of KNN algorithm. One is the classifier for classifying the values and one is for regression. So its classifier is what we will going to use, and if I execute this will give us some warnings. So for now we will ignore it. So the data set that I have is the iris, which is very structured and good for the learning purpose because it has like a proper target value, which is the name of the flower, and then there are like 3 different flowers, and for each of the flower you have the parameter values in numeric form. So since I have the iris file in the same location where this particular Python file is, as you could see, within the Python folder we have a clustering, and in that we are saying that KNN Python file .ibnv file. At the same location I have the CSV file, and you can find the link of this CSV file in the description section. So if I just go ahead and execute this, here I have imported the file. So once I have imported, I can just quickly observe the file. So iris.head tells us, okay, these are the columns which we need to indicate or use, but unnamed is the column, which is basically the row number for each of these row is something we can ignore. So what we will going to do is creating the x and y, the independent and dependent variable. So the values which are independent is basically your values for x, for example, all of these columns. So these are the variables. With the help of them we will going to predict, or we will going to classify this particular, which is dependent variable. This is a dependent variable because it is dependent on all of these values. So x equals to, so what should be the method to get only these 4 columns? You can tell me by pausing the video. So this can be one of your interview question, and remember I will keep sharing you a lot of interview questions over here. So keep watching this space, as and when it will be coming you will see that one interview question is what I will be sharing with you. And the best way to answer and to remember an answer is that once I ask, just pause the video there and then look for a way, just do a Google research, or look into a book if you have a book, that what is that question that I'm asking, because once you will research, you will be able to remember it for a longer time, and to even further remember it, just to solidify your learning, make sure you are writing it. So you write it in the comment section what your answer is, and that way once you write it you will be able to remember it for a longer period of duration, because as they say, if you write whatever you have learned, you will going to remember for a good long time. So what will be the answer? Well, the answer is iris.iloc and colon, and then the name of the column. So 1 to 5. Why 1 to 5? Because column is starting from here. So this is 0. This is index, so we don't count that. 0, 1, 2, 3, 4, 5. But why 5? Answer me that. So if I execute x.head, this is big. X.head, what do I have is basically these 4 values along with the index. All right. And for y, what I'll write again, iris.ilog colon comma -1. Why -1? Right. So to pick this value, but why not 5? Answer me that. So now this is your Setosa. Now what you can do is simply call this or instantiate this algorithm k-neighbors classifier. So if I just go down, knn equals to k-neighbor classifier and specify the number of neighbors. Now how do you specify the number of neighbors? If you have not seen my previous video, I really recommend that you see my last video, which is about the neighbors, or just search on my YouTube channel that the KNN video for theory. It may happen that I may have loaded long back as well in some cases. So number of neighbors equals to how many number of neighbors is basically, and again, this is an interview question. So remember that you should have it in your mind all the time if you are going to work more and more on the KNN, and if the KNN question is coming, you should know this. So the rule of thumb is, based on the number of observation that you have, you will be taking the square root of this. So what I'll do is just press escape, come out of edit mode, press B to create a line below, and then first thing is I will see the shape of iris. So I have 150 observation. What is the square root of 150? Well, somewhere around 12 or something. But let's say if interviewer asking you, how would you see this within the Python? Well, what will be your answer? So I really look forward for your answer. But so you can pause the video, or I will just import numpy as np, and then np.sqrt is iris. Oops. 150. Or I could say that shape and then the first variable, but for now, since it is 150, 12.24, as I could, just looking at 150, because 12 multiplied with 12 is 144, and that's why I could see that it would be somewhere near about 12. So number of neighbors, here we will going to specify 12 just for the start, but this usually is a ballpark figure. It may happen that you need the less number of neighbors, and we can see it by looking at the data that you have 4 different sections. So maybe the best way is or the 4 different variables in which the colors, or the 3 different species in the column. So 3 different species, if you know. So basically the good way is start from the n_neighbors 3, but we will go with the rule of thumb, which is 12, because I believe that 12 will increase the prediction accuracy. All right. So now what I can do is I can fit x comma y, and it shows me the k-neighbor classifier algorithm with the default parameter about the leaf size, what is a metric, number of jobs, number of neighbors, so on and so forth. All right. So once we have seen that, what do we do next? Well, we predict. So there are 2 ways to predict. One is we can predict all the x values. So if I just say, what it has done is it has predicted all the x values, and then you can compare it with the actual x values, which is basically just say y. So all of these values. So right now it is coming in a form of a series. So an interview question, how I have identified that it is a series? Well, this is by experience, but if you need to tell an interviewer how to know whether how to know the type of the column or of the data set? Well, simply use the type. So type of I, this is a series. But when you have the experience, you can just look at this and tell it right away. But how you can convert a series into an array, right? So that will be an interview question which you need to answer by pausing this video. Remember, search it and write it, because that will solidify your learning. So the answer is very simple, x dot values. And here you can see we have an array which is similar to this. Now the next question is how to combine the y values and KNN predict this particular column. So to combine it, just for the purpose of scanning the data, is y underscore predict, just one new object I am creating, pd.dataframe, and within this data frame we need data equals to, and within the data I need two columns. One column is y underscore pred, if I am not wrong, or if I have not stored the values. Yeah, I have not stored the values. So what I'll do is I will just create a column y underscore pred, and this way I can store all the values of prediction, and then I will specify it over here, y underscore pred and y dot values, because both are arrays. So y dot values and then y underscore predict. That's interesting. Well, this is not what I was expecting. So how would you put it in a proper format, like this? So that your column or these index numbers are over here and you have these two column names up there. So again, pause the video. If I can't insist enough that you should pause the video whenever I ask into a question, search it and then write it in the comment, and then, you know, see it next. Well, to answer it, the method is transpose, and if you see, in most of the cases we are predicting correct, right? Up until like 149, you can see. Since these are 150, so first value is 0. That's why the last one is 149. So that's one way of how you can predict it. Also, knn.predict. What if your interviewer is asking that, hey, I don't want to predict everything. I just want that I want to pass on particular parameters. So for example, if I just go up and show you in a context what I meant by that, hey, I just want to provide some values randomly, like 4.7, 1.5, 3.1, 0.2, or maybe 1 over here, then what should be the output? Well, in that case also, you can use the knn.predict, but with two square brackets where you can pass whatever you like. 4521 I have predicted, and or 4521 is what I have passed and it has predicted. It will be Setosa based on the algorithm that we have written. Okay, so you can pass on the values and it will give you the output, and the same output, if you have an interactive web application, you can go ahead and show it to your end user, and it will be pretty amazing, because you have an algorithm which is not only produce the result in the backend, but you are giving the flexibility of sort of a what if analysis, or what will be the prediction, what prediction analysis, where user can enter the values and they can see the relevant output. So for example, let's say you have some parameters to identify the segment of a customer. What if you know, a user is asking, okay, if I have a new customer, let me identify it with the help of the data science or with the help of the algorithm, what segment it should go. So it will specify some parameters based on what you have given in the application, and then they will be able to get to know, okay, this is the segment. So this is very, very useful application. As you could see, one example is this, but I really want to understand what example that comes to your mind based on the area in which you are working. So let me know about that, and it will be very interesting conversation and very interesting learning from each other. So this way you can have the output as well. Well, the next thing is, which I want to show you, is the train test split method. So from sklearn.model selection, import train test split. So this is very useful from the perspective that right now what I've done is we have taken the entire data set, fit it in the algorithm, then predicted on the entire values. But usually that's not how it happens in the real life. You will see most of the time that you need to test your model on the unseen data, and to have the unseen data we create a test data set, and this is something you can create it very easily with the help of the train test split function, which you can import it from the sklearn.model selection. That helps us keep the training and the test data separate, so that once we have trained the data on the trained data set, we can test it against the unseen data and see how well our model is working. All right, so for that I will create 4 variables: x underscore train, x underscore test, y underscore train, and y underscore test equals to train test split x comma y comma test underscore size. So I want to hold out 30%, and so that you get the same result as me, I am specifying random state as 1. It is just one random value. Whatever you want you can give, but if you want the result which is similar to my one, which I'm showing you over here, mention random state equals to 1. So this is something which is called reproducibility. Again a different interview question, that how you will make sure that whenever you are producing something you can reproduce the same thing. Let's say if maybe audit or maybe for some other reason it may need to happen in the future, so you can specify the random state over there. Okay, so next thing is Knn dot, well, what do you need to do? Well, you need to fit it, because we have already specified the number of neighbors. So x underscore train and y underscore train. Okay, and now y underscore test underscore pred and Knn dot predict. So answer me, what parameter I will pass? X train, X test, Y train, Y test, or something else? On which particular object I will see or I will predict? Well, pause this if you have got it. Good. If not, then what I need is basically X underscore test, because X test is your testing data set which will be validated against the Y test. Whatever will be the outcome will be tested against the Y test. So if I execute this, let's see, the outcome is this y underscore test underscore pred, and now let's see the outcome of y underscore test. So again, to convert it into an array of values, and if you see, mostly Setosa versicolor, Setosa virginica, versicolor virginica, in most of the cases it is predicting it correctly. And to combine it again, we will prediction underscore output. Let's create a new variable, pd dot data frame, data equals to y underscore test underscore pred, y underscore test underscore pred, comma y underscore test dot values prediction output. So what do I need to do? Transpose. So if I transpose, here is my output, which from a quick scan I can clearly see that almost in 100% of the cases the algorithm is working fine and giving you the good classification or the comparison between the predicted value and the real value, even in case of an unseen data set, right? So that's one thing, but apart from that there are a lot of different things. I know this is a very simple data set and everything is fine, but in a real time you will not get the data set like this. There will be a lot of work that needs to be done, because most of the time in the real data you get the values which are, you know, having very high, very low. So that means the range is pretty high, or they are skewed and not in a proper format. So sometimes you need to apply the transformation or data normalization techniques. And in this, that is something which I have already explained in one of the previous videos. But let's say maybe in the future video I will show you. And not only this, what we also have to do most of the time is that testing of the number of neighbors. So if I just go up where I've specified the number of neighbors, over here you will have to take them in a loop and then see where you are getting the maximum accuracy. And another advanced step is using the k-fold cross-validation method, which is an advance of train test split method. So all of that is basically your different techniques that one need to apply on the real-time data set. Maybe I will explain in a different video because that's again a very different lengthy topic. So just keeping the learning and advanced part in a different topic altogether. And now I hope you have learned a lot in this video. So let me know what you have learned in the comment section, and share your experience with me. That will be a way to know what you think about it. And don't forget to share the video with your friends and colleagues, because you know, if we share the learning, the more we share, the more we learn from the different people's experience. So that's about it, and I'll meet you in the new video, the new topic.